10. And before we get started with other scheduled thing, introduce Peter Yim, who was very instrumental in organizing and getting all this stuff put together. And one of the things he organized and single-handedly put together was sort of the machinery by which we could collect and beginning to build a repository. So I asked him to explain it to you, what's out there, because later we'll be talking about some of the things we could do to enhance it, and it probably should be that you got an idea of what we're enhancing. So Peter.
Great. First of all, I guess most of you probably already know what we're talking about, but I noticed there's some newcomers, so I mean this may be a repetition. We went through this slide in session 3. Essentially, this is the sort of front end whereby we are capturing colloquium inputs and the dialogue. Obviously, in the center.
You have to use this so the people out there.
Okay. First of all, this in the center box, that's the colloquium session, which is here, and of course we've got Doug's talk, we've got guest speakers, and we've got live participant contribution, and we've got slides. As some of you who go to the archived, or even, of course, you can't go to the live, but I mean the live and the archived webcast, you see slides that are synchronized. You've got the audio and video stream. One thing that's coming up, we don't have it yet, but it'll be in a couple of weeks. We'll have transcripts of all the sessions, I mean 1 through 10, and that would be sort of the colloquium session inputs. Apart from those, a lot of you have been responding on a weekly basis to the weekly questionnaires. Actually, on session 1, we had about 150 responses. And on the last few sessions, I mean, the number is dwindling. I mean, obviously, sometimes, I mean, they didn't get posted until fairly late, but we haven't had enough. So please, 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 I mean, go to the questionnaires and send in the responses. Maybe, may I see a show of hands? How many don't know how to get to a questionnaire? Oh, one. Okay. If you go, do you know the website? The colloquium homepage is www.bootstrap.org/colloquium, and that's on the first slide of Doug's, and it's actually live. So if you go on the slides, it's clickable. That takes you to the homepage, and there's a little gray box called News, and within News it says, I mean, if you click onto that, it'll say questionnaire. Another way to go there is within the navigation buttons, there's one called Discussion. If you click Discussion, it again takes you onto the page that tells you how to get into the discussions and how to get onto each of the weekly questionnaires. When you're done with the questionnaire, when you submit it, anybody tells me what happens?
You get the survey results.
Right. Yes, you get the survey results live, and then less the verbatim responses. We have not published the verbatim responses yet. We still need manpower and bandwidth, I mean, to analyze them. But they will be published on an aggregate basis without sort of direct linkage to the author or the person who made those responses, except for one. Actually, on questionnaire number 10, which is not published yet, we'll be asking you to maybe give an assessment of the colloquium that we can quote you on. That one, I mean, we'll quote you on with your name and destination. The others we will publish on an aggregate basis. The last and the most exciting one, or sort of on our front end, is our online forum. How many in the class is in the online forum? Okay, a good sort of 40% or so. Please, again, I mean, that's I think a very exciting part of the entire colloquium. So far, number of people registered for the colloquium comes to about 1,500 now. And we've only got, who has the latest number on the online forum? 130 some, right? So we've got 130 some people in the online forum. So roughly about 10% or so. So we need more people there, but it's very exciting. The postings are great. Who has the latest number for the number of postings? Eric, maybe you would know. 500-600 postings by now. It's just marvelous. I mean, so please, I mean, that's a very exciting part of the colloquium. It's online. A lot of issues being discussed, and all those. If you are already there, you know how to get there. If you're not, maybe someone could help me by telling the rest of the class how to get sort of signed up into the online forum. Anyone? Well, okay, maybe I'll do it. Again, click on the discussion navigation button. It tells you how to sort of get registered, how to sign up onto. We're using a commercial service called onelist.com for our discussion, and the discussion group is called unref2 at onelist.com. And among other things, I mean, there are a whole bunch of services that support it. The one that's being used most now is the threaded discussion. And if you're signed up, there are 3 ways you can get get to the messages. One is to have those messages sent to your mailbox. 2 is to have the messages sent to you on a daily basis as a digest. So the whole day's messages is bundled in one correspondence and sent to your mailbox. And the 3rd way is not to get it at all, but at your leisure you go into the onelist.com site and then view it yourself. That's as far as OneList is concerned. But we have also taken it one step further and converted through hypermail, converted all the exchanges into HTML pages. And again, they are available as an archive if you navigate from the colloquium homepage. Again, it's the discussion button. Click on the discussion button. There's a button called archive. And for the archive, to access the archive, you need the username password pair that is also the same one you got when you registered with Stanford. If any of you forgot that, I mean, send an email to me or to colloquium@bootstrap.org. It's the same username password pair that will get you into the archived webcast in the future, get you into the archived discussion group, and so on. Actually, the online forum supports a lot more services than just the threaded discussions. I mean, I made a posting recently. There are like 6 or 7 different services that are supported. So please try to make the best out of it. Back to Doug.
Thank you, Peter. So I just mentioned briefly that Peter had been so instrumental. It was he and Mary Dye's basic idea to try to do this, and they went and got the funding for it, and 2 of the funder supporters are here, I think, and we ought to acknowledge that during the reception. And anyway, and then putting this together was a lot of work and a lot of surprises about what it takes to do it. And Peter put this together single-handedly because other options that we were counting on fell apart. And so I just say I rarely meet somebody that's as competent as Peter is for about getting all this going. So then there's this fact of the kind of life is that Peter has a family.
Thank you, Doug, but I definitely will have to deny having done this single-handedly. Actually, we had a team of about 50 or 60 people. By the time you recognize them at the party, you'll know. But one person I have to recognize is Shinya Yamada. Over there, he supported the entire system. I sort of just said what I want to see done, and he did them all.
If that many, he must be a great manager, right?
Yeah, and it's too bad that looks like we're losing both of them, that the economics of how to raise enough funding so that Peter could have a salary never quite materialized. And then Shinya, his father's donated him and has to go back to college in Japan in a few weeks, so we'll miss them both. And
so this has been a great forum in many different media. What will there be going forward from here? Because I think of this colloquium as a start. Maybe some of this will come later, but will the Unrev online forum be the main place to meet after we can't meet here physically anymore, or will it be still the colloquium homepage?
Well, the whole idea was that this could be starting a nucleus, have a dynamic knowledge repository, and the dialogue would be about how do we get going and what kind of intelligence we collect about the options, and how could we improve it also, which is coming later this hour. And the funding situation is slightly worrisome right now, so we're just really hoping. And that's why we just make no bones about it that in any event, to make it go like it's going to warrants going, it's going to take more money and funds and people. So we got some volunteers that'll help for a while, but there's an end to that. So anyway, so yes, the whole test of it will be, can we get the resources and the people together and get this dynamically taking off? So like every other sermon you hear, we'll pass the hat. Take a collection. So it wasn't until just at the end Shinya showed me the way in which I could keep track of all these things. You've seen some of the very clumsy exchanges we've had in the past. So, okay. I worked up a set of slides to show you that if I could go through them in a few minutes I would. I wanted to give the picture about why we're going to choose to launch specifically this sort of open source and at first volunteer based and hopefully getting other people involved into the sort of low level of making that our own operations work better. And so I showed this picture again here about pointing out the thing of if you get an infrastructure of organizational things working that are part of the improvement infrastructure and you get the feedback lines going work, it's all great. But down here at the bottom is a core part of it that's that foundation such again, which has to be a source so that as you evolve processes and methods and learn more about it, you've got to be able to evolve the software tools, the tool side. And so you have to get that set up so it can evolve in order for the rest of the evolution to work right. So, you know, there are arguments people place about saying there's so much money, especially coming into Silicon Valley for startups, etc. Billions of dollars a year are going into software startups and such like that. So how would you talk about an open source way to do it as a way to try to do something practical? And we say, well, that's something to explore. And I just have a hard time seeing that the way the marketplace works, that it's going to kind of do the exploratory, wide area evolution that's needed. So the open source mode that evolved a year or two ago, and came emerged into consciousness a year or two ago, is just a very, very interesting, provocative sort of thing. So we're going to just say, okay, let's give it a shot to see if we can get an open source, open hybrid document system going. So what I want to do is is show you in kind of quick flashes some of the kind of characteristics of earlier systems we built and worked on, etc., like that, that would be relatively easy to implement soon, that could make quite a difference in the way the people involved in our site and actually reaching out from that site to other ones could actually get experiences that would be very different as an early start in all of this. And then we have 5 gentlemen here who all, we had meetings last week, and they said, okay, they'll talk. And so it's exciting. So anyway, that the business about big scale, it's got 2 ends. There's a top end where really are big, but that foundation end is something you just can't ignore. So this is like saying, again, that it has to be launched and sort of nourished as a very special part of the whole big thing. So anyway, here's some of the things from that augment system that we've been publishing for years. Is very basic, that every object in a document, a knowledge container, every object should be addressable by a citation link. So you're sitting in what you're writing, you should be able to talk explicitly about any object in there, any characteristic that you want to. So, you know, to have it so it's designed just for you point to the whole document doesn't do what it's going to do. So ours was like that, and we carried some of that into some examples we put on the website that we can show you about too. And so this introduction to this feature, we're going to show that each statement, which is what we call a standalone module, which you could say a paragraph or a header would be an example, and that was given automatically given at least 3 different kinds of identifiers when it was created in our environment and file. And so we're just going to show you one of them here and what it means. So that meant that you could sit here with a link and point to anything in an email or any other document, and including all of our software source code was that way. So an email or any document could point to any line or part of source code, or in a comment field in the source code you could have a link pointing to anything else. So it made a great deal of difference. And one of our speakers here actually lived in that environment. Andy Poggio here was a young kid without gray hair when he, in the 70s when he worked with us. So he works at Sun now, and he's got some comments to make about some of that. So anyway, we did some screen captures. So in this first one like that, a recently experimental version of the augment system, there's a special client programmed in Smalltalk for us, and it never got really done, so it hasn't been like use, but it does some interesting things to show, because you can show the screens so interesting like that. So anyway, so we got a special things to show that each one of them shows the URL that positioned the browser to that point, and then some click action that's ready to go that will do the next step, see. And so they show a succession of views a regular augment user would likely progress through, going to a file and trying to find right in what it wants. And it was in a journaled copy of the publishing paper, one that's online. It's called Authorship Provisions in Augment. It just details a whole bunch of the unique characteristics. It was published like 15 years ago. And so anyway, the way they usually approach to that thing is not just come into the front end of it with the whole document open like a book and scroll through. You came through with a view in a hierarchy, and we'll show you that it's just the top level of the hierarchy, 1 line each. And so that's the way, bingo, the thing would jump into it. With this link up here said it's in the OAD journal, it's item number 2250, and go inside that to thing that was labeled with an access address location of 7C2. And so that link is now there, and it's it's a way that you can do it. So you say, okay, I want to. I think there's a mistake in that. I don't think the 7C2 belongs in this one. Anyway, so then these buttons in the front were set up so that if you click on the middle button, it'll hoist that node to the top and open up one more level between it, still at 1 line per each, see? So let's just say we go to the next one and see. So bingo, that's what you see. It hoisted item 7 to the top and 1 more line deep, so you're looking down 1 level deep, still 1 line, and you says, oh, window views is what I like. So I click on the middle button again there to say hoist that to the top, open up another level. So that's what you get. Wait a minute. happened here? Did that? Yeah, I went to 7C, and you got one more level down there. And now you say level clipping's what I'd like. When I hoist that to the top, I want to see everything. So we said, okay, click on that, and that's what you see. It opens up all the whole material to what you see. So that's what every augment user's been year after year moving around like that with the views. And the views are something you could implement very quickly, and you go. So it's just second nature to do that. And we did it in every place. So we say, all right, that's something we could probably fairly simply inaugurate in the archives that we're building. So we look at different ways of doing that, and that's sort of what we're all going to be talking about, is some of the things we can do this and other features in there. So those label tags in an HTML document we did the same way when we convert. And so you'll see a lot of our documents that are online in the web, actually they came from Augment. So we fixed them up so that when they got over into the HTML, they had those little name tags, those labels were on there. And so then they suggested ways to deal with this. We'll just move a little faster. So this next slide will show a designated location and a page on our website providing details about this colloquium. And the URL that got us to this location in the web page at the top, and then the result of a right button click. So in a Netscape browser, the right button, if you click on a link, it'll tell you it picks up a copy of that link, so you could paste it into any other thing, which would turn into a link to point right to that paragraph in that file whenever you exercise that link. So this is the URL that got us here, number 6. So you can see this item 6 here, and you see that down here at 6B1 did a right-hand click, and we could copy that link. And suppose then we did that so that the next time then we picked up and pasted that 6B1 into something, an identifier, or what we did then, somebody, Frode Hegland, suggested, well, why not make that button actually a link to itself so that you pick that up so that you could click on it and go there or do the copying. And we said, oh, then that's a lot more like what Augment was, so that's great. So this is what happened then when you picked up and you clicked on the button 6B1, it hoists it to the top. Boom. So moving around inside of here and being able to access and address individual passages, just we found in the old days this was extremely valuable. So we're saying, how can we fix that? So anyway, the idea of doing a post-process, when things go into the hypermail anyway, in which they're hyperlinks, to say, let's do a process that installs that kind of little tag buttons on every paragraph so that the email that you guys contribute gets processed so that you go look at it and every paragraph in there is now addressable. So if somebody else wants to comment, they can put links in there pointing to specific places, and it boosts the capability a lot. See. So anyway, this is the cross-linking that we could get, and then one of the advantages of that too is that if you provide some backlink management, then like the CRIT system that was discussed by the Tanya Jones, where's she hiding? Where's she hiding back there? In the Foresight community, is saying, well, then you can tell when you look at a paragraph who's been citing it from any place else. So the dialogue gets much more enriched like that. So anyway, so these the general things that we were talking about wanting to do here are listed, and I don't, they're just like saying, well, one of the things is we had an interface so that whatever terminal we're using, if it was one in this set that was available, the interface automatically put a little file tied to the interface so that it made it interact with the particular terminal you have, which is what you'd like to have, is if you're going to interact with any handheld thing, and all the different variations you want to have handled, including very high performance. And you want to support grades of user proficiency, which means you got to have very flexible options about what kind of interface you have. So people that want to really get in there and fly and are willing to do the training can have functions and ways to execute them that other people don't. So anyway, so optional and macro command setup is part of the thing that will show you how it was done, executed. So if there are a bunch of commands in there that'll do something, you can write a little macro description that whenever you execute it, it'll cause the thing happening, just as you were doing it by hand. So one of our innocent young women trainers got together with somebody else, and they actually built an accounting system that way. It's amazing. So anyway, and user preference profile. So basic user interface architecture there had a lot about what's potentially available in the future, and the idea was you had a virtual terminal controller, you had a type of user viewing operating, you had a command language interpreter that was going to interpret your actions to do something, and it picked up a file that was called the grammar that described how it is that you wanted, when you actuate something, you wanted to turn that into actions. So that's what they call your command language grammar. So somebody could fix you up with that, so you could have your own way of expressing how it is you would like things executed and viewed, and something like that. So anyway, so in the slide A that has these things, and I think I'll move faster, but it's saying this user interface was a front end, the virtual terminal controller actually actuating with the terminal, but it looked at this terminal characteristics file that was your option for how you set it up. Then a user profile file was fixed by the command language interpreter whenever you logged on. So your own user profile said, hey, what about these other things you want? Which grammar file would it load? So what were the commands it would recognize and how? And command scripts could be read into that same thing, affecting that same grammar, and all that interact with the back end. So this was an intermediate thing that we actually happened to host on the server, but it could have been in the like that. So that was something that we just been waiting. The model matured then through this next kind of a slide. So one thing we call a reach through thing that we couldn't get funded in there, and actually did a lot more for multiple complex projects, and it just. I want to hasten to get a chance for these other guys to give a presentation. So this was sort of a picture for the way we were going to do this with this intermediate thing here, which could give you coordinated access to many servers and an interface server that you and your client like that could interact with. So it just was a general sort of thing, and we're talking to people in McDonnell Douglas about how could we go into their computer-aided design systems and data systems and such and that, but could never get the funding. So about a year ago or something, when we got a little time to do some studying, and Adam and I were looking, and we ran across the IBM Webby system, and says, oh boy, it just looks like the answer. So anyway, this transcoding intermediary is what this IBM thing offers, WBI, web-based intermediary, and this is an active link that will take you to see about that. So anyway, so got this proposal based on our intuitive sort of support for that, and we have an IBM expert here. Where'd you sit, Paul? Paul Maglio, are you here? Is he here?
He was here earlier.
Boy, drive him home. Anyway, so this is what happens if you go to that site and study it if you want to do that. But the idea of this general intermediary is your browser sends something, a request, like an ordinary, when you click on a link. And that takes care of that and sends it to an ordinary server, and it sends back its ordinary thing, and the general intermediary can translate that and change what you actually see. So we say that's a very, very good thing. We say, look, what we'd like to do is specially coded in here. So our special coded thing goes here. That is something that maybe the end server wouldn't know what to do with. But Webby picks it up and says, I know what to do with it. I go get that, and when I pick it up, I translate it into something else for you. So that's what we do like that. So, oh boy, it could even do something like what's common in our world is you could make a link whose address to say, go to that particular place there, and you'll find a link, and take that link. And it's that target I want to get, but I'm using this indirect path that'll go wherever this intermediate link points to. So, hey, Webby could do that for you like that. And just little things like that just start immediately enriching the environment considerably. And so there was another thing that Neil Scott, who was sitting right here, and he's going to explain to you that came out of this Archimedes project oriented for the physical handicap. Just a really neat thing that this special total access system here that can drive a system in here by actually knowing, programmed to actually actuate different buttons, etc., and icons, and can act just like a real user. But it can get its instructions via some special way. So you could have all kinds of users here. And his was designed for the handicap, which is a great boon, because then they can move whatever they can move that comes into the special thing and instructs the computer to do stuff. But this means that if people that want to really try far out ways in which I'm going to fly this computer don't have to get limited by the kind of GUI that's there. So anyway, in this coevolution thing, what we hope to do is get a number of communities to start using this Webby thing in order to make changes. And the very early ones are just changes the addressability and the viewing that you can do, but those are very potent sort of things to get experience. So people could come to our site and take links and start following things around. They would just be very different from what they'd see if they followed similar links from their own stuff. They'd just get a regular page. So, so anyway, a lot of things can come of it. I feel like I like to get these guys on the air. So this is one kind of a picture. If you're going to have communities working on this, you really have to get those that are interested in evolving the user system and the conventions and the tagging that you can put on and how you start managing the dialogue, and instead of depending upon some of the things the user mail does with their threads and stuff, you could get brand new kinds. And there's a friend of mine, Jeff Conklin, who took an idea that other people had evolved, I guess at Berkeley, called issue-based information systems, and he evolved it into the graphic world like this, so that it really helped decide. You could actually have a record of the way an issue evolved with the dialogue about it, so that you could track back and find out what are the prevailing issues of importance. And then Jim Spohr and his EOE archive, where they went back and really find how do you determine the sort of attribution of whose ideas were responsible for shifting on that. So these things are all just what needs to be improved. So we're hoping all that could work. So anyway, these are things I'm expecting you to read very rapidly. Because there really are a lot of things that Webby could do for that. So we have now coming for you some energetic... Pardon? Oh, the beginning, you're right. Thank you. Never underestimate the wisdom of somebody who's just sitting there. I'm not kidding. It would be really, really interesting just if we could integrate the knowledge and the innovation capability of people in this room. It'd be some collective IQ. Boy, it'd be terrific. Okay, so we have an order. So first on is going to be Adam Shire, and I promised I would be able to get his system in there. Okay, Adam? So, Adam used to work at SRI as an honest researcher, and now he's an executive.
First, I want to say I'm a little guilty that Doug rushed through just to get to us. I think it's an honor. I'm going to keep this really brief, and there are basically three things I want to accomplish by this at this talk. The first is Doug was talking about increased participation. So we've been watching why this approach and these technologies and this methodology can do things like solve world problems and all of that. But in today's community, where people are pouring billions of dollars into Silicon Valley, I thought I'd spend just a few minutes to make a little bit of a business case about why this could fit into something called business-to-business e-commerce markets, where there's really a lot of money going into. So that way you can go back to your friends who are in B2B startup companies and say, this is what you should be doing. The second thing I'd like to do is a very brief proposal about how do we organize a little bit to move forward into subgroups or teams around
I'm coming from a technology perspective here, but you'll see a little bit of that. And my third objective is to introduce some of the other people who are going to be speaking after me by giving their views on what applications we should be addressing, perhaps what technical approaches we should be taking for moving forward. So I'm now working, as Doug said, at a business-to-business commerce company as Director of Advanced Products and Research. What is business-to-business e-commerce? So basically, it's like commerce for consumers, such as eBay and Amazon and these small companies like this. But someone realized that businesses actually spend 1,000 times more money per year selling to each other than actually selling to consumers. So this is a really good space to get in there. Why does what Doug is doing and Bootstrap Institute is doing have anything to do with business-to-business commerce? Basically, any of the commerce companies, any of the companies in this space say there's really 3 C's that have to be addressed. These are content, community, and commerce. And I think already the content and the community aspects Doug directly addresses, and the commerce aspects rely on the content and the community, and we'll see a little bit of this later on tonight. A few things sort of struck me during Doug's talk today. So he was saying, well, you know, there's every technology company is moving out, and here's the anticipatable future. I've realized since joining an internet company, you know, with internet time, 2 years is beyond what anyone can see in this space. You know, 6 months from now, we can maybe imagine what will be there, but 2 years is forever. So all of these things about nanotechnology and others are going to be dramatically pushing the limits of how we need to integrate technology. But even simple things like e-commerce is going to dramatically improve. So we need to have capabilities that can address these problems. Another thing Doug was talking about is global scale. Why can't governments organize to do these types of cases, and maybe states and at different levels? So VerticalNet, the company I work for, is the basic idea is to organize online communities around different industries that will allow trading in this particular space. One of our communities happens to be the state of Maryland, so who are trying to say, well, there's actually a lot of knowledge and content and community and commerce that goes on by the state. We should organize as a particular community in a business-to-business space. So there's direct relevance with some of these topics. So in a way, I think this may be a little bit difficult to read, but basically, in business-to-business commerce, there are net markets forming around different communities or vertical industries, and you can think of them in Doug's terms as NICs. So we have some companies or groups of companies who are really interested in metals marketplaces, and others in chemicals and medical equipment and high tech. For all of these communities or trading communities, they need content being brought in, such as articles, case studies, reviews, particular news events. So enabling tools that allow the participants to dynamically come together and start sharing information is really, really important for creating a successful B2B enterprise today. So the B2B people out there should be looking at these types of techniques. Additionally, knowledge and standards are the things that are really going to drive e-commerce. If you're going to have companies that need to share information and exchange information, that's not a very simple problem. Standards such as XML have begun to address this. However, you still need to have what are the vocabularies and processes going to form that will leverage XML but enable the exchange. So creating dynamic environments where people can coactively produce these standards and comment on them and discuss them, very, very important for getting successful B2B commerce. So these are just 2 quick slides on why sort of dynamic knowledge repositories, open hyperdoc systems are critical for success in the B2B space. My third and final slide is a little bit organized in a technical sense, but here's a simple architecture where we're going to, if we had this wonderful OHS, it's going to be driven by a number of applications. And the requirements from these application groups, such as B2B here will say, I need to produce this type of information and exchange this type of information, will inform the rest of the process. We're going to see some talks from other people coming after me about, well, what should we be doing first with our OHS system? I want to emphasize, I agree sort of with the bootstrapping idea of Doug's approach. So things that we are using to actually produce, to improve what we're doing, are the things that we should do first. So for instance, the way we communicate through email and news, that may be a very good candidate. The code that we develop, if we could develop better tools to develop the code, we could develop the code faster. Augment, so just what I mean by augment is learning. Here, Doug has a particular set of documents in a system. If we can inform people or find ways to inform people better personally on what this system had as capabilities, that will enable more people to get excited about these types of techniques and help move forward. So we'll have a number of applications, and I propose that we organize a set of teams around what those applications should be and what are the requirements that are moved forward. Based on the applications, this will help determine what types of knowledge or documents do we need to produce. Is video going to be important, and should it be a high priority as a first one? What type of linking will really enable our applications? Do we need backlinks to really further particular discussions, or indirect links for different pieces? What types of formats do we need to be able to convert and import, such as the one list being converted into hypermail? Once we have sort of document formats to process, we need to figure out how do we store it and what capabilities do we need to manage these documents in terms of security, versioning, journaling. We can't do everything. We have to sort of start prioritizing. I, of course, have my particular opinions about which applications and formats and technology should we develop, but these are sort of teams that will need to interact to provide consensus on where to move. Intermediaries, so Doug gave a few words about how things like Webby can really enable capabilities in an OHS space. And finally, how do we build what does the client interface look like, and do we just use a standard web browser? Do we go build our own web browser? There's a range of possibilities, and we really need to. There's actually a missing arrow here, because what we can do will then feed back. Applications will feed into this need as well. So the proposal here is a generic one. Let's try to organize into teams and topics to discuss these interfaces and actually start moving forward on an appropriate path. So the speakers who will follow me will be discussing either somewhere in applications and document or some technology approaches to be using, and hopefully that'll be serve as an introduction to what follows next. Thank you.
So our next speaker, Eric Armstrong, is the terror of our dialogue world out there, because he ends up with more stuff out there than anybody else. Hey, where'd you go, Eric? Is that it? There you are. Okay.
Thanks.
You get Mike?
Hi. So the talk is Creating a Super News Group, which has probably got to be one of the worst titles for a project anybody ever came up with that could really use a better idea. I just saw on the email list this morning Hypermail, or Hypernews, which struck me as a great name, and I wish I would have thought of it. In this fifth session of this colloquium, I presented an idea that what we should really target for development of a DKR was open source development. because doing that would give us maximum leverage to building the kind of systems we need for in all the other areas. And I focused in that talk a lot on the advantages of using hyperlinks and hierarchical structuring for source code. So there's a big picture that we want to get to, a product or a mechanism that will enable a whole wider universe to be more effective. Now, taking from there, I want to focus in, narrow, what is the smallest core nucleus that we can build that will help us to get to the target place. And the reason for getting to a small nucleus is several-fold. You want something that is going to be useful as soon as possible so you can use it to do your own design with. You want something that will be widely usable. A news group of some kind is going to be usable by everybody, not just source development. And by giving you a highly constrained initial target, it ups your chance for success. And the reason for that is when you're dealing with a complex area, design and development is a process of exploration and discovery. It's not an assembly line process of just simply spec it and build it. So you ratchet. You design a very simple system. You build features for it. To get the next level, you have to redesign. You redesign that level and you keep the same features until you test it and you know it's working, and then you add the features that new design allowed you to add. You ratchet your way up to the larger picture, and that gives you the ability to expand from there. Now, this all started with Doug's observations that, hey, we already have an email archive that's in HTML form. I happen to think that's a great achievement because translating plain text into HTML in an intelligent way is not an easy problem to solve, but they've done that. If we added an intermediary, he suggested we could add the kinds of links that Augment gives you and take advantage of what they've already adduced as being necessary in this domain. And the interesting thing, what really got him excited was when he realized that, hey, if we did that, we could probably use this for any HTML page out there and change the way people use the web. So that's an intriguing prospect, and he convened a whole bunch of us here together to start talking about it. And there's an interesting comment in the newspaper the other day that when you get 6 engineers in a meeting, you probably get about 12 opinions. This is no different. We had lots of interesting ways to go about the project. We also had some convergence on a couple of key areas that make sense. And again, it sort of emphasizes the fact that we need this system to explore the design space. We need something along these lines that will help us be more intelligent about how we carry on the discussion. We want to be able to do it remotely so that people out in the web space will be able to, we get the best brains in the world on the project. It's infinitely better than even all the best brains in this room, which is considerable. The one list challenge said, hey, how about if you guys that are there physically adjacent put together an initial system that we can then make use of to design the next version? Because it's really hard to get started with the tools we have at our disposal today. Now, and if we take this tack, we begin, what we want to do really is to eliminate the copy redundancy in the email archives. What happens when you get an email is you reply to it, you have a copy of it, and you insert your comments. And now all the old stuff is already still there. It makes it very hard to search, to reuse the content. And with this kind of a mechanism, you get sort of documents that grow organically as people add to them. Now, I'm not addressing here some of the issues that what you really want to do at some point is to distill the documents. You want them to grow, but you also want a distillation process. That's a second-order mechanism that has to come after this one. Oops. So the data model you get when you look at an HTML document is a structured document on the left. It's called a document object model in XML, HTML terms. It actually goes deeper than this. Each block there is sort of a unit of structure in this sense. What you want to be able to do is respond to an element in that message, not have to respond to the message as a whole. That eliminates the copy redundancy. You already have threading in your mail list client, hopefully. And what we simply want to do is add that hierarchy, bring it down to the level of the message, and take advantage of the same facilities. Now, the response is, again, also a tree of each of which can have its own responses. So here's an idea of what it might look like. On the left is an HTML document as it would normally appear in a browser. We added some pluses there. Those are similar to the kinds of icons in the Augment system. If you switch to a outline view, you would simply see the H1 and H2 tags you see on the top right, or switch to the single line view, which gives you a little more information. And what's interesting here is that in that single line view, again, this hierarchy is now clear. Looks like the list of folders in your directory structure or in your mail processor. And all right, moving forward from there, we do one more thing with the intermediary processor, which is to add those little links at the end that are self-referential to point to that paragraph. That lets you copy them, put them into your own message, or it allows for the client that's dealing with this system to intelligently respond, to identify the piece of that message that you're responding to. So in this kind of a system, when a couple people respond to you, it could look something like this on the left. Get on a little thing here. Fred responds, just like in an email message. It's attributed. You know who it came from. And it's in line. It's in context. It's not disassociated from the text it was originally referring to. And you might have a button back at the end where you click to hide those things, so you can see the original message rather than any responses. Oops. Or another option was you might have an icon for individual messages, and they could show up in another window. The point being that...
Your buddies are going to get their 10 minutes.
Yeah. I'm racing. I'm going to quit at about another couple slides. Right, so the point being that you have different client potentials that you could build on the same fundamental system, and you want that flexibility. Now, the third item there is that you want to create an open standard. The reason for that is that it lets lots of people get into the game. You want lots of people devising servers, devising clients, coming up with the best possible interaction mechanism. What we come up with may or may not be best. Given 100 organizations out there doing the same thing, one of them is going to emerge as a winner. You want to preserve attributions, preserve the discussions, be able to reuse them. Several things you don't want to address right up front are those things that just make the problem too complex to solve. You don't know the answers offhand. There's a lot of things you have to leave out version 1. Architectural components that we've looked at, intermediate processing, the weblets are a great way to get your hands on that DOM and modify it inside the context of a browser or as a standalone application. And then XUL is another mechanism that's being developed as part of the Mozilla browser. Okay, we identified 3 development stages. First is simply browsing to be able to look at it, get those features. Second is if you maintain a local copy, you get interesting capabilities such as you already have in your email. Be able to highlight the new and unread portions of a document. So when an update comes in, you automatically know what you haven't read yet. Another is the ability, now you can say, I want to ignore this whole thing, or I might want to see just new versions of the document, or maybe I want to follow all the discussions in my inbox. Finally, there's a more integrated editing system. You need versioning and stable anchors, and I'm going to end here so that everyone else gets a chance to spend a few minutes. But the rest of the 7 slides are just a review of some of the design options we looked at. Again, there are multiple ways to skin the same apple, and we need a system like this ourselves to make sure we intelligently explore the design space.
So next we have Jack Park, who works in the same place that Adam does. And I hadn't met him before last week, and I'm really pleased about it because he's bringing you guys some kinds of orientation that I've been hearing about for years and saying that kind of stuff has to get integrated.
I have one, if I can get this on. I have one objective and not much time. My objective is to introduce the attractor basin called knowledge representation. I've heard people refer to it as a black hole.
Now, Doug was talking about surgical implants of knowledge devices, which it made me think about what would a implanted memory device in your tooth do to oral exams. There's a timeline that brings me to this session, and I just want to take a brief moment to go through it. In the same year that I graduated from high school, Doug wrote a paper for the Air Force that fundamentally described what we're all doing now. Some 25 years later, I did an expert system for the Air Force that basically changed my career path into the area of knowledge representation and that sort of thing. I later built a program I call the Scholar's Companion, and its whole objective was to enhance the IQ of the individual using it. I spoke of something called the apparent IQ of the human computer. Doug speaks of the collective IQ. So there's a tremendous parallel between what Doug has been doing and what I've been doing. And by the way, there's another parallel. I used to milk goats. No, I'm not. Actually, goats are easier to milk than cows, by the way. What I want to talk about is the... I won't go there. I see the OHS DKR package as a knowledge management system in a slightly different way than Doug has been talking about it, and I think that's why he asked me to speak today. I say that it can contain domain knowledge of the kind that physicists have and cow milkers have and so forth, but the OHS itself can provide us with a knowledge editing, viewing, browsing environment. We're very interested in having multiple ways to view that which we call knowledge. And that, in fact, is where I wish to go very briefly. Many people have different ways of carrying their knowledge. We have in this room a brilliant mathematician. I tend to think in terms of concepts and relations. Others think in terms of logical equations. And there are many other ways. We don't have time to go too far into them, but let's look at sentences, a big picture. You think of a cat as a mammal. You can say it in a logical statement, in this case a prefix variant where you see that you are expressing the fact that a cat is an animal. Or you can put it out visually in concept maps. And I'd like to draw your attention to the fact that almost everything that has been presented to you here has been presented visually in almost exactly that form. Now, I drew from John F. Sawa's concepts, which he calls conceptual graphs, and we'll go there just a little bit more. I really want you to recognize the fact that I can represent graphically facts, I can represent statements of beliefs, I can represent just about anything I want in a graphical visual way, but I can also represent it electronically in the memory of the computer. And by the way, that's a hot link so that you can see where I shamelessly copied this graph off the web. You should go and read the whole paper, by the way. I have gone and coupled something that Donald Knuth did called literate programming with what I call knowledge engineering. Now, where we're going with this is as follows. Literate programming allows you to write a document with lots of prose where you are essentially saying, here is what I want to do, here is how I'm going to do it, and oh, by the way, here's the code. And the neat part about it is that you can send that entire document through a filter to a computer, and a compiler will pull the code out and go ahead and build your program. Well, what if we did the same thing with reference to knowledge, chunks of knowledge, where we were able to write a book and in that book have our diagrams, and have those diagrams go directly into the memory of the DKR and become usable by others. But meanwhile, you still have a text document where others can say, I see where they came from. One really useful thing about this is that it supports the constructivist way of teaching kids how to do things. The kids can sit there and construct their own little diagrams very similar to the one we saw before. And this is a great way for teachers to probe the depths of the knowledge of the child, is to let them express it the way a lot of people think, and that's visually. So we need an editor for textual materials, our narratives, our links. We need many editors for formal knowledge materials. We need to be able to build concept maps, logic statements, mathematical equations, and so forth. And I close with just a little sketch of how this sort of my vision of using the OHS, where individuals at a console create a document, they write their background narrative, they enter their knowledge structures, and they enter their links, and it becomes a permanent record within the DKR. That's it.
Thank you very much. Well, these are things I've been waiting for, so thank you. You know, I get the images of all the different ways you can kind of portray and manipulate, and it's just terrific to get examples of them showing up. Okay, Andy Poggio. Here's someplace. Hey, what the hell did
I've disappeared. Looks like I must be in another directory.
Don't go away.
I'll be here.
Yeah.
There we go.
Yeah, you have to take a mic. So, Andy's the kid that once worked with us, so he's got some experience about using Augment for stuff, as well as now works at Sun as a manager, no less. It's hard to imagine that kid being a manager, but...
You know, people who work for me say exactly the same thing. There goes my first boss, by the way, out of school. Talk about incredible luck. So I want to spend just a minute giving you some sort of a pragmatic picture of why I care more than ever about the things that Doug is doing in things like open hyperdocument systems. As Doug said, I work at Sun Microsystems. At Sun, we build computer systems of all sizes. We build little tiny ones. The Sun rays that we make are basically a frame buffer and a network interface and really nothing else. And we build big giant ones, enterprise 10,000s with tens of processors and gigabytes of memory and terabytes of mass storage. And so I want to give you sort of a brief picture into that world and how what Doug is talking about really applies and how we really need it. So one of the changes that's happened over the last decade or so is it used to be that hardware people drew things and software people wrote things. Well, it's all looking more and more like software, and even all the hardware people are doing a lot more writing and a lot less drawing than they used to. And everything is scaling up. System boards, the circuit boards that go in your computer systems, have 18 layers and more of interconnections. In a single integrated circuit, we're moving above 1,000 pins into the area of 2,000 pins just for one integrated circuit. Even the little thing that the silicon die connects onto that maps the pads on the die to the actual pins that comes out is a little circuit board with a few thousand connections on it. Even those are problematic these days. Integrated circuit gates for ASICs, 2 million and up. Processors beyond that, 8 million and up. And operating system lines of code, tens of millions. This stuff is all essentially information, looks a lot like text in a lot of cases, and it's all being scaled because of Moore's law. All this stuff, including the size of software, is really being enabled by what we can do with Moore's law. What's growing even faster than that, which I think you'll all recognize, is networking bandwidth. Right? Networking bandwidth is growing faster than Moore's law. It's basically because of demand and optics and a few things like that. Whereas Moore's law says everything doubles every 2 years or so, networking is going up by about a factor of 10 every 2 years or so, outgrowing Moore's law, causing some interesting problems for us. So all this information interfaces to the other bodies of information, and there's all kinds of opportunities to get it wrong. Most of these things are at least semi-automated, if not highly automated, but there's always a human aspect, and we're always pushing what the tools can do, right? Because we're always growing faster than the tools are being developed. So you can make mistakes going from mapping the wafer to the pins on the IC, from the pins to the board, from the board to the software driver, from the driver to OS modules, from OS modules to other OS modules, and from the operating system applications. All of those interfaces and more have opportunities to get it wrong, and it happens all the time. And it's not getting easier, it's getting harder. So there's lots of information linking opportunities that an open hypertext, hyperdocument system could tie together and make this all a lot easier to do. There are requirements documents. Those go into specifications for products. Then there are hardware designs, interfaces, and the source code. Like I said, Verilog, which is what we do our ASICs in, looks a lot like C, as does Java. There are software design interfaces and source code as well. There are external dependencies from suppliers and parts and partners and strategic development relationships. There are schedules from PERT charts. There's user documentation. Then when you finally start shipping something, there are problem reports. All this stuff should get tied together. They're fairly elaborate systems for each little piece, but there's nothing that ties it all together in some usable way. And to make this tougher still, especially in Silicon Valley, people move around. Right? A processor these days takes 4 to 5 years to develop. You can expect something like a 10% change of people working on it every year, so there are a lot of new people coming in. They need to get up to speed. They won't see those links that some of the people that have been involved a long time will see. So something overriding that ties this stuff together, that gives you different detailed levels of view and automates a lot of this would be hugely, hugely valuable. And any investment we make in this would be terrific. Today, those environments are very domain specific. They have to be. But they aren't interlinked well with the other domains. There's nothing that facilitates collaboration except some basic things like source code control. It's all got to work reading and writing. Reading is interesting, but the creation part's the writing. And we need to do it with source and version control. So I would love to see an open hyperdocument system come to fruition and apply across this kind of broad domain. That's it.
So we don't have to quit right at 7. We can run 5 or 10 minutes later because of the way the tapes go.
Oh.
And so how's that?
Maybe get back to the beginning of it.
So hit 1. Go 1. You could. So you know, these other guys are bringing things in that have mutual interactions that are very important. So his field is just very important, as I've indicated before. So start talking.
Okay, I'll talk fast. My main work is ensuring that everyone has access to the information. We're creating an infrastructure where information is being made available, but if you can't use the tools that are provided, like the keyboard and mouse, or your eyes, you are blocked out. And this is actually very serious in many places where societies are adopting things like information kiosks where you get your money or pay your bills or renew your driver's license. Someone who can't use that device is disadvantaged. We started off here at Stanford doing this, and we've been getting inquiries from all around the world saying we want to do the same thing. And so I've added to my original thing, which is looking at individual needs, abilities, and preferences is something we have to take care of, to add and culture, because different countries have different ways of doing things, and because we're becoming global, we have to take note of that. For many years, we made access by modifying the system that people would use. We'd get inside the computer and change it. That has become totally impractical. You know, the computers change faster than we can change them. And also, if you change a computer, you then have to look after it for the rest of your natural life. It's a problem. So the system that I developed, we call the Total Access System, says let's split the problem into 2 parts. Leave the target system alone and give the person something that allows them to interact with any of the things in the environment. And the nearest analogy I've come up with is my spectacles. If I take them off, you all look really funny. You're sort of blurry. All right. I put them back on, and by magic you're there. These are my business. I've been wearing glasses since I was 3 years old. There are other people here with glasses on. If we swapped our glasses, it wouldn't work. Some of the people that say the infrastructure should look after it, it's like saying every window in the world should be automatically curving to adapt to my needs. It's not going to happen. So we have to allow people to move around and use the things in the environment by bringing with them what makes sense for them to bring. We call that device a personal accessor. The piece that goes between the personal accessor and the target is a little box where we put the translation material to make this thing operate the keyboard and mouse and read the screen of the target system and turn it into a standard thing here. Now, a lot of the computer companies didn't like me for a long time because looking in that hole, every computer looks identical. Right? A Sun, an SGI, a PC, a Mac, whatever. They all look the same thing because we made them all understand the same set of standardized commands. The idea is very simple. It's one of those things that people see it and say, oh, that's so simple. I could have done that. Yeah, well, it's a little bit like Doug's things. You know, it's obvious once you've done it. But what we're working on is that between the user and the accessor device, whatever that might be, it's very specific to the user. It's human-centric design. It's what does this person need? Between the accessor and the tap is universal, so that any accessor can work with any tap. And between the tap and the target machine, it's totally machine-specific. So the key thing is that we've taken away the knowledge of the machine from the user. They don't need to know. And so some quick examples of this in practice. The person I'm going to show you in the next photograph broke his neck in a diving accident when he was 17 years old. He came to me as a student here, and his system has a speech system running in this notebook. He has his Mac tap here connected to a Macintosh just hidden off the side of the screen, and he has a head tracker. And I defy anyone to use a Macintosh more accurately or more quickly than JB. He worked with me for about 5 years, and he's just finishing an MBA at Berkeley now. I don't know if I'll ever get him back, but basically the key thing in working with someone like JB was no one ever consciously was aware, apart from new people, but the people who worked in the project, you never thought of JB as being any different to anyone else. The only thing we did in the morning was we'd slip his headset on. We got the robot to do that. That was our intention, but I never got enough faith in the robot to let it, because it'll end up wearing the headset on his nose. But the head tracker allowed him to do all mouse functions, and his voice allowed him to do everything else, clicking the button, whatever. The way we're working is to allow people to mix and match things like head tracking, speech, foot switches, mouth switches, whatever. But the target system remains totally unchanged. We then have the situation where, Sun may think that all the computers in the world are Suns, and Microsoft thinks they're all PCs and so on, but really there's a few others. And we find that Judy, who came to us, she'd reached pretty high level as a programmer here in Silicon Valley at some of the big companies, and she'd reached the point where she was the person you'd get when you call up with a problem, and she'd help you walk through it. But her elbows gave out with tendinitis, so before I met her, she'd been out of work for 18 months. We had her back up to speed in 1 week, and her job was to work out how we say the same thing to the speech accessor, and we get the same result on all of these different computers. So at this time, all she has to say was talk to the PC, and then just say whatever she's doing. Talk to the Sun, do exactly the same thing, and exactly the same thing would happen. Eye tracking, normal sort of schemas is an infrared light source shines on your eye. You get a different reflection from the retina and from the front of the eye. You calculate where the person is looking through a camera. And in this case, the person is looking at a little keyboard on the screen and typing just by looking at the letters. For a long time, it was seen as the Holy Grail. Turns out that it's actually not, because our eyes don't work the way we think they work. They actually jerk around, and our brain is integrating all these images, and it's very, very difficult to tie it together. But we've got, we think, one of the best eye tracking systems now. We're working with a German company to mount the whole device in a little thing that just sits down on your face, and it's head tracking, eye tracking, and voice. Head tracking does the mousing, eye tracking does the selection from menus and things that you can do very well, and the voice does all the commands. humble switch. You think of a switch as just a switch. Put a microprocessor in there, teach it the codes, and it becomes a very helpful tool because other accessors can tell the switch, oh, until I tell you otherwise, you're an enter key for a sun. Or until I tell you otherwise, you're the left mouse button on a PC, or whatever it might be. Or I'm going to give a very complicated command, and if it screws up, here's what you have to do to undo it. And so you can have, a logical forward, a logical undo, whatever. Handheld accesses. I can drive a Sun or a PC or a Macintosh totally from my Palm Pilot. Never touch the keyboard and mouse on the other thing and have total control of it. And the Sun and whatever else is totally unmodified because the tap is seeing exactly the same thing as whether I'm talking to this or using graffiti. It still looks the same. So this is a system where we're working on how to balance out where do you use speech, head tracking, eye tracking, foot switches, handwriting, whatever, because each does a job well. For a person who is disabled, you're pinned into taking one particular choice. For the rest of us, we can mix and match all the rest. Ben is not disabled. He's a very, very bright programmer here at Stanford, graduating from CS department. But he was using all of these different functions together, and we're working out, an eye tracker to select from a menu is like magic. Because when you use a mouse, you move the mouse to it, then you do something, it opens, you then look at what's happened, move the mouse to it. When you use eye tracking, you look at it and it flows open and your eye naturally flows to the next thing. And so the menus just ripple. And it's like magic, it really is. But okay, haptics, blindness. What we did to the blind people was basically take people just as qualified as any of us sitting here and turned them out on the street about 5 or 6 years ago because they couldn't handle all the new software that came in that was totally graphical. We're working, this was a prototype of a device we called the Moose, right? Mouse with muscles. And what it is, it's a mouse that's got 2 thumping great motors underneath the metal here that lets you feel where it is. It's evolved into a practical mouse that has little motors under here. It can't compete with a moose in the sense that with the moose we can take you where we want you to go. With this one it's more psychological sensation of you going there, but we're looking at how do we tie this into the system. I included this drawing. This is something that Adam and I worked on for 6 months, evolving for a grant proposal we're preparing, and I put it in because this part here, the accessor, looks rather like that drawing Doug has shown us several times where you have the user interface coming in. He had a terminal file and the grammar and so on. Where we're looking towards is having a lot more information about the real world that we're interacting with, but that it's my version of what needs to be done and what's out there, and I'm interacting. It knows a hell of a lot about me. It learns, but we still have full control of the systems. Rushing on to the next part, that's the piece that goes in the hardware end of it. The other part that I've been working on for quite a few years now is, as I said, we started getting inquiries from other countries about, oh, we want an Archimedes project too. We like what you're doing. And currently we're talking with groups all around the world about establishing a similar project. And the goal is get them up to speed with what we already know, help them make it indigenous so that in Sri Lanka, for example, we may supply some little module, but they supply the rest of it to make it an indigenous industry, and then get them involved in helping us with the research that still needs to be done. And currently, I have quite a few Japanese engineers, Sweden, Britain. We have people coming and working the project here and then going home, and so we've sort of got the sharing going on already, but we want to make it more real-time, distributed around the world. And looking at all these dots, and there are countries I haven't been to yet, so I know for a fact that New Zealand and Australia are going to sign on as soon as I go and tell them. But there's a lot of other places. And it looks like the basis of developing a NIC of people around the world interested in disability and aging and the technology that goes with it. The model that I evolved here is share existing knowledge, get funding, seems to come up all the time, perform academic research by tying in the universities, perform applied technology research by having the places that look beyond how do we take the research and make it practical. No point in doing it if you don't disseminate it and deliver it. and then share the new working knowledge. And this is where the feedback comes in, is that in this diagram I have here, which I use as a roadmap of when I talk to people about it, is I've deliberately drawn the Archimedes project. In fact, we finished signing the papers today for starting a Archimedes International, which will become the umbrella organization to tie this all together. I deliberately did this 2 half circles so that it folds back on itself to give the feedback. But if you run down there, it's all the things I just said. And just to give you an idea of where we're at, I keep joking with the people that if I get any more people, I've got to get a bigger computer. But this is to give you an idea of the network of different groups that are already involved in just what we've been doing so far. Archimedes Cairo is actually starting. We've got one in Izuka City in Japan is starting. We've got several others that they're getting the money together to start, and so on. So I see this as a real tangible example of where people could get involved in doing something that has a very good outcome. It's not competitive in the sense that, I can't work with you because my boss won't let me share any of the stuff I know. So I'm going to go straight to this last page here, which is next Thursday. I thought, since you've all been coming at 4 o'clock on Thursdays, next Thursday, anyone who is interested in the possibility of an ongoing involvement and thinking things through, you're invited to have a session at Cordura Hall, which is the other end of Panama Street, back by campus towards the medical center. Purpose is to develop ways to develop a global DKR that looks at technologies related to disability and aging. And the thing that I see is that we're all going to need it. And I don't know whether you want to use it as a forum to get the people who may be interested in the technical side of it. We've got a lot of room there. We can share it, spread out if people want to do it. So anyway, 4 o'clock next Thursday. Don't break the pattern. Just come here subconsciously and other end of the street.
There's something about the idea of collaboration. You get bright guys together and things could happen. So I just want to mention one thing that I really like to work on is being able to give demonstrations. I'd like to be able to, for instance, demonstrate the augment system. I'd like to see demonstrations of other things, but I'd like to capture them in ways in which they are part of an archive, so you can point to any, you can link in to them. So we're trying to find some way in which we can give some demo of augment, for instance, and it takes a long time to show it all, but we could just get it on the archive. So if anybody is interested, let me know. And meanwhile, I don't want us to be late for all this hoopla, and I just want to tell you this has been a real experience, and I hope it isn't the last I see of you. Well, at least I'll see you at the reception, and thank you for coming.